Number 72. You're shown two pictures, C and D. If C represents 2 molarity aqueous sodium chloride, what is the concentration of D, a solution formed by dilution of C with water? And then you have another question. So basically you got some 2 molarity sodium chloride. Let me write that down. 2.0 molarity of NaCl. And it looks like the white ones are going to be the Na pluses. The cations are usually smaller than the anions. And there you go. So what you're doing is you're taking a solution which is more concentrated, and you're adding some water, and you're getting a solution which is less concentrated. Look, there's less ions in the water. It's more dilute. It's less concentrated. And the idea here is that if you count the number of particles that you see in these same similar volumes, we should be able to figure out the new concentration. So looking on the left, we can look at either one. If you look at the chlorines, for example, I see in this amount of solution, I count 1, 2, 3, 4, 5 chloride anions, and there's also 5 sodium cations. So just looking at the chlorides. So you got 5 chlorides over here, and in the same amount of volume, after you added water, now they're more spaced out. There's less chlorides per unit of volume. There's only 3 chlorides. And what that's telling us is the concentration of this is lower than the concentration of that. It's only 3/5 of the concentration of that one. So you can write a little equation. You're looking for the molarity of the more dilute solution, and just by counting the ions in the pictures, we can say that the molarity of D is going to be 3/5 of the molarity of C, because I count 3 over here and then 5 over there. So the molarity of D is 3/5 of the molarity of C, and we already know the molarity of C. We can plug that in. So 3/5 times 2 molarity, and that comes out to 1.2 moles per liter. The part B says if the volume of C is 100 milliliters, how much water is added to form D? So if you got 100 milliliters over here and you have this concentration, and we just figured out the new concentration, we should be able to figure out how much water was added to get this. And we can use the dilution formula. One way to do this problem is to figure out, the easiest way is to figure out what's the total volume of this. We know the volume of that, it's 100 milliliters, and we know its concentration, and we know the new concentration. So let's figure out the new volume using the dilution formula. M1 V1 equals M2 V2, or we could just write it this way: the molarity of the concentrated stuff times the volume of the concentrated stuff is going to be equal to the molarity of the diluted stuff times the volume of the diluted stuff. That's just like M1 V1 equals M2 V2. So here we know MC and VC, and we know MD, so we can find VD. So solving this equation for VD, it's going to be equal to MCVC over MD, and plugging in the values that we already have. So this is going to be 2 molarity, 100 milliliters, and the new concentration is 1.2 molarity. So the molarities cancel, and you're going to be left with units of milliliters. And solving, we get 166.66 milliliters, which rounds to 170 milliliters. So the new volume is going to be 170 milliliters, and that means that 70 milliliters of water must have been added.